I chose neuromuscular, specifically the topic on counter movement jump sequence and how it relates to muscle contraction. The eccentric loading phase initiates a stretch reflex and primes motor unit recruitment for the concentric reaction. And so additional force is created from stored elastic energy within connective tissue components of the muscles. And so there are three stages, and the first phase would be the eccentric phase, consisting of loading through a pre activated muscle tendon action from lengthening contraction. The second phase is emirization, which would be the lowest point of movement. And this transition is from eccentric to concentric, and it shouldn't have a pause at this stage. And so the last stage is an immediate muscle tendon shortening reaction that turns into a jump. And so basically what I explained was what you do for a counter movement jump. And on this slide right here, it's the student's outcome of doing the counter movement jumps, which are located in the orange. And so on the next slide, I'll be talking about muscle contractions, explaining figure A, B, and C. So starting with A, the muscle contraction is initiated by a motor neuron impulse or an action potential, and the motor neuron releases acetylcholine, which opens up ion gates in the cell membrane, allowing sodium to enter the cell, which is depolarization. And so, if the cell is sufficiently depolarized, an action potential is generated and a muscle contraction occurs. And so, when the motor neuron is activated, all of the muscle fibers in the motor unit are stimulated to contract. And so, for the B figure, the action potential travels along the plasma lemma, then moves through the T-tubule system, causing the stored calcium ions to be released in the SR. And for the C figure, calcium ions bind with troponin, and then the troponin moves to the tropomyosin molecules off of the myosin binding sites on the actin molecules, basically opening these sites to allow the myosin heads to bind to them. And so once a strong binding site, my bad, and once a strong binding state is established with actin, the myosin head tilts, pulls a thin filament past the thick filament, and so the tilting of the myosin head is the power stroke. And so energy is required for the muscle contraction to occur, and the myosin head binds to the high energy molecule ATP and ADP. My apologies. ATP and ATPase. The head splits ATP into ADP and P, releasing energy to fuel the contraction. And so basically the end of the muscle contraction is signal when neural activity seizes the neuromuscular junction. And so calcium is actively pumped out the sarcoplasm and back into the SR for storage. And the tropomyosin moves to cover active sites on the actin molecules, leading to relaxation between the myosin heads and the binding sites. And so like a muscle contraction, muscle relax muscle relaxation requires energy supplied by the